Hello students! Today we're going to continue graphing quadratic functions, but our goal is going to be to figure out where the vertex goes so that when we draw our graph, we can know that our vertex will be accurate. The vertex is the point on the parabola where the shape changes direction. All right, I'm going to draw in the x and y axes. And I'm not going to use the same template that I've been using because I don't actually want the x-axis to have the tick marks, and the same with the y-axis. Because we're not going to be looking at a specific parabola, we're going to be looking at a generic parabola. So let's draw a parabola here, something like that. Now, every parabola has a point that's called the vertex. And that point is the lowest point on the parabola if it's opening upward, or if it's opening downward, it's the highest point. It's basically the point where the parabola is changing directions. And if we draw in the vertical line, I'm going to do a dashed line that goes through the vertex, we call this line the axis of symmetry, because we have symmetry in the shape. The left-hand side of the parabola is a mirror image of the right-hand side across the axis of symmetry. Now, our goal today is going to be figuring out how we can decide where the vertex is going to go. And this symmetry actually plays a role in it, because what I'm going to do is I'm going to plot the x-intercepts. If we look at the x-intercepts, and you look at the vertex, where the vertex is along the axis of symmetry, that axis of symmetry is exactly halfway in between the two intercepts. And the reason for that is because of symmetry, we know the distance from the axis of symmetry to the one intercept is going to be the same as it is to the other. So we know that the axis of symmetry is halfway between the two intercepts. The way that we can figure out how far that is to the right, or the way we can figure out the x-coordinate here, is by taking the average of the two values of the intercepts. And that x-coordinate is going to be the x-coordinate of the vertex as well. So this is a fact that we're going to use. The x-coordinate of the vertex is the average of the x-intercepts. And we can use this to get a formula for the x-coordinate of the vertex. Now, I'm going to put this together. It's going to be a little bit of math, and it's going to look really complicated at first. But once we go through and simplify everything, it's going to be very, very simple. So we've said that the x-coordinate of the vertex is the average of the x-intercepts. Now, when we're averaging two numbers, what we have to do is we have to add them and divide by 2. So we want to add, we want to add the two intercepts together and divide by 2. Now remember that we find the intercepts by setting y equal to 0 and solving. So we need to solve 0 equals ax squared plus bx plus c. And we know that the solutions to this equation are going to come from the quadratic formula. Specifically, x equals the opposite of b plus the square root of b squared minus 4ac all over 2a, and the opposite of b minus the square root of b squared minus 4ac all over 2a. So we've taken the two solutions that we get from the quadratic formula, and we're averaging them by adding them and dividing by 2. If this was the final formula, you probably would hate me, and I would completely understand, because this is an awful formula to be plugging in just to figure out where the vertex goes. However, when we simplify this, it's going to become so much easier to work with. All right, so the first thing we're going to do is we're going to recognize that these are two fractions with a common denominator, and so we can add them by adding the numerators. So what we're going to do is we're going to put all of that over 2a, and then we're going to add the numerators. So negative b plus the square root of b squared minus 4ac, and then plus negative b, which is the same as minus b, minus the square root of b squared minus 4ac, and that's all over 2a, and then all of that is still over the 2, remember? Now, there is some canceling here that is beautiful. We've got a positive square root of b squared minus 4ac and a negative square root of b squared over 4ac that cancel out when we add them together. They become 0. And then what that leaves us with is negative b minus b over 2a all over 2. Now negative b minus b is negative 2b, so we've got negative 2b over 2a all over 2. If we look at the fraction up here in the numerator, we can simplify by canceling out the 2's, so that's going to give us the opposite of b over a all over 2. And if we take something and divide it by 2, it's the same as multiplying by 1/2. So this is the opposite of b over a times 1/2. And when we multiply that together, we end up with the opposite of b over 2a. So this, first of all, this formula is so much nicer than what we started off with. Hopefully you're not hating me anymore. And this allows us to figure out the x-coordinate of the vertex. Now, once we have the x-coordinate, we can find the y-coordinate by just plugging in this value for x. It's really not that difficult. So using this, we can figure out exactly where the vertex is. And then once we have the vertex, we can plot the x-intercepts and also the y-intercept. I drew this one so that actually the y-intercept is going to be way off in the distance. But for all the examples we're going to do, we're going to figure out the y-intercept, we're going to figure out the x-intercepts, and we're going to figure out the vertex. We're going to plot all of those and one more point, and that's going to give us a very good graph of a parabola. And more specifically, it's going to be accurate where it needs to be, because the vertex is probably the most important point on a parabola. For the graph, the vertex tells us where it changes shape, but if this parabola represents some sort of situation, like if it's an upside down parabola, let me just sketch one. If this is a parabola that represents the trajectory of a rocket, for example, then knowing the vertex tells us how high that rocket has gone. If we have a parabola that represents some sort of a profit function, then knowing the vertex tells us the maximum amount of profit that we can get. So we really want the vertex to be accurate. That's why we spent this whole time looking at the vertex. And then also the x and y intercepts end up being nice too. So in the next video, I'm going to go through one example step by step where we find the x and y intercepts, we find the vertex, we've got the axis of symmetry, we've got one more point, and we have beautiful graphs of parabolas.